Hi everyone. Today we'll look at the graphical user interface in Python. So let's look at the user interface, the history of a user interface. The first, uh, the pattern of user interface to the computers is a command line interface. This is the first the generation and also still uh, the most powerful and uh, uh, most preferable the user interface, particularly for developers. Developers are not using graphical user interface. So most of the case, graphical user interface is a subset of a command line interface. Each command of uh, the computer language is nothing but the program that was uh, developed and implemented by a developer. Okay, the command line interface is one of the user interface. Another one is a graphical user interface. That's what we are going to learn today. And then web-based interface. This is the most simple ones. The web browser provides you to interact with the back end, the services and computers. And then touch interface. From this point, the user interface is not really explicitly different from the previous, but related with the technologies and devices. The touch interface. Um, your laptop computer has also a touch interface. Uh, and I think smartphone, of course, allow you to communicate through touch interfaces. And then voice and natural language interface. These days, as you may know, the OpenAI and ChatGPT, the services allow you to talk to in vocal messaging or the text in natural languages. Augmented reality and virtual reality interface. Most of these interfaces are very useful for medical purpose, particularly rehab, hospitals, employ the augmented reality and virtual reality interface to, for a patient to respond to the computer simulations. Okay. If you go to, I think many of you had that experience or heard of that. Particularly in our area, there's a Burke rehab hospitals. Many years ago, a few of my graduate students had an internship at that Burke Rehab Hospital, where at the time Burke Rehab Hospital was one of the hospital run by Cornell University. I believe that right now Cornell is separated from there, and I think that is run by Montefiore right now, at this moment. But anyway, at that time, the Cornell, the hospital and computer science faculties working there, and I collaborate with them. And one of the virtual reality interface they actively use to some patients who do not respond, who do not have senses, who do not have, the patient do not hear, patients do not have sense of touch, but patient has patients open eyes. So we can play on the monitor some of the messages, some of the animations. If it is not message, if it's not text, but some messages, then the patient look at that monitor and the eyeball moves, respond a little bit. That response can be captured by the gesture sensor, which was developed about a decade ago by Microsoft. So if patient responds the way animation being played on the terminal proportionally in time and efficiency, based upon that, the medical data can be collected, and further research has been performed. Anyway, that is one of those. Brain-computer interface. So I just explained, together with the virtual or augmented reality, with the brain-computer interface. Of course, some other cases, brain signals can be censored and use that. Okay, so user interface developments in native Python can be done by one of those. But we are going to use the most primitive components, tkinter. This is the most primitive. So TK has been developed many decades. So open window associations developed that, and since then the first generations of the graphical user interface to computer has been developed. It was in 1980. Macintosh, which is one of the first computers developed by Apple, before Windows systems was developed. And Apple developed the Macintosh. Macintosh as a graphical user interface. At that time, the other side, the other device, as opposed to Apple, which is now Windows, but at that time it was a DOS program, DOS, diskette operating system. Computer was developed by IBM. IBM has developed that for multiple more years before Microsoft was invented and adopted that. And then Microsoft company mimicked the Macintosh graphical user interface on their Windows systems. So first generations of Windows is really awkward. It's not really, it cannot be compared with the Apple graphical user interface. But anyway, that's what has happened at that time. It was really stabilized since year 1990, 1990s. And yeah, still a little bit of the distance between the Microsoft Windows systems and Apple's Mac OS interfaces. But anyway, this TK and TK systems has been adopted by Apple Computer and Sun Microsystems. two major companies adopted it and to improved, enhanced. Sun Microsystems was the company, leading edge company in 1980s and 90s. That company developed Solaris servers. Solaris is highly sophisticated Unix operating systems. Most Fortune 500 companies uses Solaris servers, and then mid-size and small-size companies uses Linux operating systems. So that's a top end operating system, so Solaris. Academia uses Linux operating systems because it is cheap. But about decades ago, universities have to use Solaris operating systems. One small the computer, the price is about $10,000. It's a good size, maybe $50,000. And if it is a servers, then $200,000. Right now, good server, if you the equipment itself is not that expensive. I think a couple of thousand. I think $5,000, right, for servers. So maybe only 5% the price that used to be in the area in the age of at the time use this graphical user interface TK and TCUs. For Python, based upon this tkinter or tkinter, py qt py side, Kiwi, Flask and Django, Pygame, and more. So tkinter, if you use the tkinter, then you have to, this is the module, so you have to import that module. You can simplify that, this alias tk, if you like. And then, we need to have here indentation. Yeah, up to here. So print hello world root. You know what I want to, before I forget, I need to 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 and 1 2 3 4 and the root main loop. Yeah, we can push this also. And then finally you can do say hello, then it runs. Okay, so I'm gonna save this and so hello world. And then this tkinter has a class called the tk, uppercase T and small k. Invoking this class name, then remember that there is a init magic function is activated to construct an objects. So the object of a tk class is constructed, and we call that object ID, object name root. This is a variable root, right? That object from this point can call any methods that are available on this class tk. One of the method is title. So we can say hello world tkinter, then the title, window title can be created by this. And then there's a button, and then the tk has also a button, another constructor. Button is a class. So this class is available being invoked by this object tk. Okay. Oh no, this is one of, right, same thing here, another class. So button has parameters. So first parameter is a container. This button should be contained in this object root. What is root? Root is tk. So button is contained in this button, and then we call text hi and hi tkinter. When that button is clicked, then we can activate another function which is called say hello. We didn't define that say hello here, but if this is clicked, then in response to the event of button click, a function needs to be activated, executed. And this button needs to be, this is a button object. So from this button class, an object is constructed, and we call that small b button. And that button needs to be packed with the container root. And then root dot main loop. This tk class has a method called the main loop. What this main loop can do is to see this. This is when the graphical user interface. This is not static, which means there could be multiple events available. By clicking this, if there is a text field, then user may be able to enter some text, and many of such the graphical components, UI components, may be included in this windows. So that events takes place somewhere here and there. So this window itself needs to be refreshed in response to, not in response to, but continually, because events, one events after another events takes place. So that should be continually refreshed, which is done by main loop method, which is available in this tk class. Okay, so how many classes being used here? tk is one of a class, button is another class. How many methods were used? Title is a method, and open loop, the main loop, that is another method that we looked at, right? And then how many methods are invoked in this program? There is a magic method. tk class has a magic method, which is defined by double underscore init and double underscore. Same thing here in button. So magic method each of this class, and then explicit method title, and the pack main loop. Those are the methods. All right. And then there is similarly others available, but I'm going to skip this. Same thing here. There should be indentation from here there, right? So push it to there. Okay, graphical user interface in tkinter. So you can, I wanted to look at Python tkinter from Google, not Google Colab, Google search engines. Then you can see some of the description about the tkinter. We call that API. Okay. Any functions associated with the TKs? Many. Bell, main loop that we looked at, destroy, and also, of course, magic functions, title, geometry, what is the function main loop, executing main event handler. So when event occurs, then we have to, that Windows needs to be refreshed, as I explained it earlier. How to code in GUI. Less likely to develop graphical interface. We are not going to develop graphical components, not UI itself. Okay, we are not UI developer. We simply invoke something already available. Something means the classes about graphical user interface. So in the earlier, last few weeks, we looked at object-oriented programming. So that concept is exactly the case here that we are using. Okay. So graphical components that are already developed and provided. So what we need to do is that we need to create an object of some class already available for the GUI user interface. And then also we invoke method through these objects. That is all we need. That is the concept that we learned the previous the classes when we looked at object orientations. So object-oriented programming is a new concept. It's not really a new concept to you guys, but it was a really new concept to me. I learned this object-oriented programming after I graduated. Okay, so this object-oriented programming, the first language was Java. It was announced in 1995. So I learned the coding in 1985. So I've used it for 10 years, the programmings. C, there's no C++ at that time, and Pascal, and Lisp, there's a Lisp programming, that is for artificial intelligence programming, or Prolog. And then in 1995, Sun Microsystems completed the new language called Java. And then I took the Java class from Sun Microsystems. So first generations of Sun Java developers. And then late 1990s, when we had Y2K crisis, it wasn't a really crisis at that time. 2000, the year 2000 year. You guys may not know that, but at the time, it's a new millennium approaches from 1900 to 2000. So they're worrying about the computer technology crisis. So anyway, around that time, Python was invented by one of the researcher in Switzerland physical lab. That was Python. Python now is so popular, right? But anyway, so graphical user interface, you have to first create an object of TK. There are two things that you can do. You can create an object of a canvas, or you can create an object of a frame, one or the other, or together. So in this semester, you guys can learn how to do with the canvas user interface and also frame user interface. Canvas, you may feel literally on canvas you can draw something. Using frame, you can develop some of the real business-oriented systems. So there's some text field, there's some button that ask user to click to enter, and some menus may be provided. All such things can be done in this frame. Most of the work can be done in this frame. This is more fun because it's a drawing. Maybe computer game, or maybe some of the teaching material for those who needs to get some impressive motivations, right? Like I said, for rehab, the hospitals may develop some of animations. Animations here also, animations, and they are in this categories. So what we are going to do today, we're going to look at Python on Canvas, and then next class will be done for Frame. So Canvas, graphics on Canvas and menus on frames, and they can work together. But we are not going to do this. This is a little bit of a trickier approach in Tkinter. It's not impossible, right? We're not going to handle this. But I included enough examples in the book that I wrote. I'm not sure if you are still referring to that textbook. It was not textbooks. The book that I introduced to you guys, and also it is available on Amazon. So there you can find out more advanced graphical user interface. So Canvas widgets create TK objects, and then the title create a canvas objects. That's what you need to do. Then you will have this. Okay, CIS 131. Actually, this is CIS 131. Yeah. And then you can even further from that canvas objects to invoke a method. The method that we are going to use most of the cases is create line, create rectangles, create line, then this is XY coordinates. It starts from the point, the X coordinates 0, Y coordinate 100, which is about this, right? From here to X coordinates 200, Y coordinate 0, that is here. So we draw a line, fill a red, so it is in red. I want to make it dash rather than solid lines, so it can do the dashed lines. And then create rectangles, XY coordinates here. This is, if you have rectangles, then if you know the coordinate, the 2 points, then you can draw, right? Upper left corner and lower right corner. 2 points is fixed, then you can draw rectangle. That is exactly what we are doing here. So this is upper left corner, 50, X coordinate 50, Y coordinate 25, which is, I believe, maybe this, right? And Y coordinate X 150 and Y 75, somewhere there, right? And then rectangle that. The field blue, the other one field whatever the color here. This is RGB code. So red color 47, green color 60, blue color 42, RGB code. So each color can be generated from 1 byte long. 1 byte, the value is 1 byte is 8 bits, right? So 1 byte, 8-bit long. So here is let's say if we start this from the index 0 to 7, so that is 8 elements can be in. Each element can be represented 0 or 1, right? That is a binary code, 0 or 1. So 2 values can be fit in here. So combination of all these 8s, how many different colors, how many different density of color can be represented? That is 2, because 2 values, 0 or 1. 0 means that's off, 1 means on. How many bits available? We have 8 bits available. So 2 to the power 8 means 256. Right? So if it is red, how many reds color can be represented? 256 red colors can be represented. It's not only one color of red, 256. And then green, same thing, 256 different kinds of green. Blue, 256 different kinds of blues. So we mix red, green, blue, each color in different density. Therefore, for example, a little bit of red, a little bit of green, and a little bit of blue. That is exactly this. Out of 256, only 47. 47 of red. Out of 256, 60 green. Out of 256 blue, only 42 blue. We mix those 3 colors. Whatever that is the color. Okay? So I believe that is the color here. This is the color. Remember that is outside, in the middle of that side? Because inside that is yellow, simply yellow. So you can say in text yellow, or you can give real the RGB code. Same thing. If it is blue, then if you can convert this letter blue to RGB code, then it is £, blue. So blue is all set, all others unset, which is off. So the other 2 red, there's a 0, 0. So no red. Green, there's a 0, 0. Why we say 0, 0? It means 256 in hexa code, that is nothing but FF. As we count from 0 to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and if you count more, then if in decimal counting system, we have only 10 values to count to represent a number, right? That is decimal counting systems. But if we want to hexadecimal, which is 16 different numbers, then there's no other numbers available, so we borrow the number from alphabet. So A. After 9, instead of we call 10, 10 means we go back to here. So 1 digit can be increased. After 9, in single digits, the number will be 2 digit in decimal. Therefore, we call that 10, right? So rather than go up to the digit magnitude increment, we still remain in the single digits. Then we instead we borrow A. Instead of 11, we say B. A in decimal, that is 10. B in decimal, that is 11. And 12, that is a C. 13, there is a D. 13, 14, E. And 15, that is F. So up to 15. So from 0 to 15, how many numbers? 16 numbers, right? So 16 times 16, that is the same as 256. So this is a 16. F is another 16. If we multiply 16 by 16, that is 256. So rather than using the number, 3-digit number, we want to stay in minimal and meaningful 2-digit numbers than F and F. Therefore, we have 2 digits, 0, 0, 0, 0. And then full true blue, which means by setting all the number here, 1, 1, 1, 1, then that is FF. Okay, so this is RGB code. So pound sign 0000FF, that is nothing but blue here. They are the same. And this canvas and also point is on a, you can make a list of points and then call, create a polygon. Polygon uses points. So these are the points. To draw like star or cross, how many points that we use? We need to use 1, 2, 3, 4, 5, 6, 7, and 8 points needed. So XY coordinate 1, 2, 3, 4, 5, 6, 7, and 8 points coordinates given. Therefore, we can make this points outline green. So outline color green, fill in yellow. The width number 3, and then this canvas needs to be packed, and then main loop continue to refresh. We put them together, then it'll be like this. Okay, we have rectangles, lines, and star all together can be like this in one Python program. So we're going to work on canvas. So today hands-on is canvas, and next week hands-on the frames. Okay, that's a week minus 1 means before the final exams, right? So week before the final exams. After this, then you guys have final exams. So graphical user interface lab cannot be done on Google Colab, but we will work on Python. Finally, we're going to work on Python. Someone may ask, why not on Google Colab? Anyone has any answer? Why we? It's not impossible. We can do it, but it needs a lot more codes. A lot more such codes are not directly related with the graphical user interface. But something, here's the reason. Google Colab is not on your laptop, right? Google Colab, whatever the code, that code is on cloud, Google Cloud Systems. If it is rendered, then it can be rendered at the Google Cloud somewhere. That cannot be represented on your laptop device. Unless you do many technically intensive codes involved. So lots of headache. Therefore, I decided not to do that. Okay, for you guys. So we'll come back to each one's your laptop, and we're going to work on laptop. Okay, rather than going up to the Google Colab. Think about that. Why we cannot? Okay, I would say why we can. Technically possible, but lots of hassles. So we're not work on this Google Colab. But come back to Paizo. Okay, I think this is the theory that I can share with you guys. And then I am going to bring up the Paizo. So click Paizo. So new Paizo here. So remember that we need to do import, right? From tkinter, I want to import everything, and then because there's a tk class available, and we want to construct tk objects, then we need to invoke a method. One of the primitive method developed in tk class is the underscore init underscore. So the double under method or magic method. So we call that tk. And then if we do this, let's save this anyway. So let's save this on, let's say 131 in class. I want to say here GUI 1 canvas. If I run this, it says nothing has been done, right? So object is created, but I didn't hold that object. By holding that object just constructed from that object, I can invoke one methods after another and after another and after another, so that we can call this, say, maybe top rather than root. You name it, okay? And then if it is called top, then I think you need to do that should be refreshed. So top dot didn't give me any the hint. So main loop. Okay. So save it and hit enter. Therefore, I have this, right? So tk number 2, whatever that. So yeah, this is previously it was internally created, but not displayed. But if we in graphical tkinter, if you have an error, and then you run the same program multiple times, and when it comes to successful completion, then all of the previous display can come up at the same time. Right now, 2 windows came up, right? One that was previously invoked, but it was not displayed, and the other one right now. So let's start with if we have top objects, then I want to put title. So let's say, hello, my CISC 131. Save and run. then it have hello my CIS 131. It can be enlarged. And then we can create a canvas. So now canvas objects. So canvas is another class. And the first one is, what is my container? I want to put this canvas on the container TK. And what is the background? I want to make background in RGB code. RGB code start with a pound sign. And then I want to do FF9911. What that means is FF, so pure red, 99 of green, and 11 blue. So it is more like red side rather than blue side. Okay, so maybe I do not know the name of that color. And then width, then you can define, say, 700, and height maybe 500. Once you construct an object, then you need to assign that to an object called camv. Okay, and that camv should be packed with this is a canvas object that should be packed with the container top. Then we can see that. Without this, let's start with without this first. Without that, it's nothing, right? Canvas is not packed with that. But when I do packed, much nicer. This is something that I made. Canvas packed. This is the color that I generated. Pure red, green 99, and then blue 11. If you guys remember this, you can clearly see the difference. If I swap red and blue, red 11, blue pure 100%, then you can see the difference quickly. This is that color. Okay. All right. And then I can do what I want to do here, because we looked at the object orientation. I want to put this on the object orientation. So let's class called, let's say, my GUI, my first GUI. And then we can make a tab, and outside we need to call this, right? So we can do my object equals my first GUI, like this. Then this should work. Okay. We can parameterize this more. For example, the width and height. Instead of this, we can say we parameterize this with width W, height H. Those numbers can be received by the init function. Then you need to have here init functions. So df underscore underscore init underscore underscore, and then it should be self, and then width and height. Okay. And then you can say self dot I wanna bring this up. self.top is that, and also you need to do here self.top top title is that, and then this also self.canvas and self. Let's make this. We create this another definition. So def camber self. If it is camber, then that is a reserved word. So we need to do. Oh, it's not reserved word. Camber. Okay, fine. Okay, so then here I would say, okay, self top and geo, it's not given to me yet. Remember one of did we have somewhere? I think geometry. Okay, so I'm going to use that geometry. Geometry, I believe we'd say W. I want to see the proper way of using geometry. I think we need to say, yeah, simply, I think double times width times height. I'm not sure. We need to figure that out. And here also width and height. And then I can push this, that. Okay, let's see. And then we need to, I'm going to use this as W, and then what we can do here, self dot width is set to width, self dot height is set to height. Then we need to put here self dot width and self dot height. Self dot height. Then we don't need to put here self. I think this. Let's see how it works. Then we need to put here, let's say 700 and 500. Remember this, the constructor, the object can be constructed by calling the class name, then this magic function can be activated. This magic function expected 2 parameter, so we need to send the 2 arguments. Okay, width not defined. Geometry this. Maybe it is this. Not sure. But it's not really defined that way. So we don't need to put this there. But we want to put here width and height. Then we don't need to do self that and self height. And we don't need to do this. What this means is that we simply use this. We hard-coded 100 times and 600. I would say 800. Okay. It was not really defined that way. But here my object now invoke camber. When I invoke camber, then I need to send WNH. Remember that he says WNH, so I would say 700 and 500, 700 wide and 500 height. And then when I call this, then that is constructed, but why color was not. Cannot invoke canvas command application is, oh, this is, let's see. Oh, there's no error. Then why background is not properly? Height and width worked, but background was not really emulated here. But if you do this outside of this, I think it should work like this. And if you can bring width and height, and rather than invoking this, simply put here 700 and 500. Save this. Still, color was not. Invoked. Oh, I think I know why. I want to go back to the way that we defined canvas, and I want to put width and height. Here I'm not going to do that. Now I know why. Here, because this top is not just top, we need to say here self top, self.top. Okay. And then when I call my object dot camber and 700 and 500 height, then I need to have here colon save. Oh, still color was not. Why color is not? Background. Oh, I need to put here self. If it is there, then still is not. Canvas. Oh, canvas. Canvas. Okay. Still not. Canvas. My object canvas 500 and width and height. If I don't call this, what happens? This is okay. Only, how come it came up here? Without canvas. Okay, like this. When I call this, it's not really stable. Self.top with the height. Let's say self.top, self.cam. Oh, now it works. Yeah, because self was dropped here and there. Okay, and this should be also self-top dot main loop. Oh, self is not defined there. Yeah, simply that. Okay, so that is there, and we can do further. I want to create on that canvas, something that you guys already know. I'm gonna copy and paste it. I'm gonna call this canvas. Okay, so this should be canvas. Call. So what I did here, create rectangle, create line, another rectangle, an arc, oval, see what I have. So when I have that, canvas packed. I think I need to do canvas factor first. And then another pack here. So when I run this, all right. So what I want to do here, I want to make this another more on cam self. Okay. So when I run this, I don't have anything right now here. And when I do here my object dot more on cam, okay, then I will have, this is a little bit weak. The emulation is a little bit weak. So what I did, first create an objects, and then canvas, only I draw canvas. Okay, when I close this and save, I think I need to restart the shell. So clean shot shell. And when I call this name top, not defined because of that, then I think I need to put that there, and it should be self top, and that is run. So I need to restart the shell and run it so that works that. And then I want to do restart the shell, the canvas there, and I want to include that more the images, I mean the graphics, right? Then no, I need to do here the restart clean canvas. I want to run it. Okay. What is the error? Warning: the secure coding is not in our store state. This is somehow the errors of this Paizo itself. So 500 and self. Okay. So when I remove close that and reopen Paizo and run, still the same thing. So to make it clean, I need to go back to the way that I used to do. So I want to make it simple. So I want to put here width and height. I'm not going to run this. To not make one, separate method altogether. Then I will put this at the end. and run it. Yeah, clearly, if it is the case that it always fine, because this is very straightforward. All can be done at once, right? Okay, then on this, I want to make it 1 star. Okay, so I want to give you that star. I already defined, so I want to make this star. I want to make a proper indentation, so everything should be pushed back further. Okay, so they are pushed. So I have this initialized. This is one method. Another method that I created, star. Then that another method should be done. I know why the other one was not working, because in graphical mode, if you run everything on one method, then it work. But if you have multiple other methods, then here's what you need to do. You need to do self dot and this top needs to show when the next method can be emulated. So there is a another function called after. Then you can put here some millisecond. I want to put that on 1 millisecond, and then star that is on the self. So you need to do self dot star, and if that self dot star needs a parameter k and all, then you can put there, say 5 and 10. Okay, so this is some of the algorithmic codings. Given k and all, k is 5, r is 10, so angle 360, so 360 angles can be divided into 5, and then initial coordinate, x coordinate is 500, y coordinate 150, and then it can be draw some of the length, so printed angles. See here, finally here create lines, x1, y1, x2, y2, black. According to this, that should be done this many times. So that can draw stars. I'm not going to explain that algorithm here, but let's see how it rendered. 37. Oh, this should be. Or thing should be inside that for loop. No attributes. This is not start, it should be star. Remember here, star and star. Okay. Math is not defined, so what you need to do is we need to import math here. Math and run. Oh, very good. This is a star. and then in this then I need to put self dot I want to call canvas here, canvas dot create polygon, so I'm gonna put that here, create polygon. This is hard-coded XY coordinates. So this is star 1 points, 1, 2, 3, 4, 5, 6 points is given. And then when I run this, then I can have this fill in red. So actually the polygon is from here 1, from here to there, 1 points in the polygons. So 1, 2, 3, 4, and 5. Okay, and then the fill in red. So whatever there that is in red. So this create polygon created this big star, and this small star was done by these algorithms. From here, that is algorithms, and this is the big star. Okay. I want to. So this code did that. I want to go back to the way that we initially tried to do. For example, if I want to create this, because I want you to do the homeworks, so more canvas, and then I want to make this. There is more canvas. And this should be done on here right after this. Okay, so from here there, that is one in it, and another one here. And then I need to put in the same way, the way that I do here, self dot top dot after. Again, I want to put in 1 second self dot more camb. More camb does not need any additional parameters, so I want to stop here. This guy needs 2 parameters, so K and R. I gave 5 and 10 here. Only this. Okay. So by calling this one the one initializations, then as it initialize, before stop it, it also activates another function here, more camp, and another function, more, star. So 2 things can be drawn. So when I call this, let's see. So what's Oh, I need to put here self. Self should be there. Yeah, so that I have what happens here when I create an object of this, then it automatically initiate this, invoke this function, right? This magic function. This magic function can do only the larger container and then canvas. Immediately after the canvas, in 1 milliseconds, it called more camv. More camv draws everything about this. And immediately after that, in 1 millisecond, call star, which is this function. I mean this small one, small one and bigger one together, right? If you want to make separately this, then you can do that too, right? If you want to make this separately, then you can do df more, I mean big star, and then self, and that is this big star. Okay, big star. Then after this, you can do here self top dot after, and in 1 millisecond self big star. Okay, that's also, then you need to close this and click this, and everything can be done, right? So 3 steps here, because I made how many the method that I created. I method in this class, in addition to this magic function, magic method, I have more camv, star, and big star. 3 methods. Therefore, I need to put here 3 ways of invocation of those using after functions. So an after method can hold some millisecond. After that, call that functions. So this is one sub method. Small star, there's one sub method, and big star, there's another sub method. Okay. Okay, I want to do animations. Create another. In the main animation, then you need to do also tkinter, import everything in that tkinter, and then you need to import time, because animation plays over the course of time. Okay, so I want to create draw and W and H, width and height, and then I want to say top equals TK, and then top dot title. I want to put here enjoy the animation, and I want to make canvas. Canvas equals canvas, and it is contained in top, and then background, FF 9911, and then width equals W, and height equals H, and then that camv should be, I want to put some coordinates there, which I made. I want to copy that and paste it here. So 200, 400, that, and wanna put these comments. It's not running right now. Oh, I want to save this into the okay here. GUI to animation. Okay, and then I can do draw 700 and 500. You can make anyway 700, 400, 500, 400. It doesn't really matter. And then you can run this, see how it works. Canvas is not defined. I defined the canva, so it should be canva. So run this. Root is not defined, of course. I put here top, so it should be top. Okay, so all together came up. The real ones here, this, right? I have this. This is like a Pac-Man. So I want to call this Pac-Man. I'm not sure you guys can see. There's a Pac-Man game. I think that is the first generation of Pac-Man game. So I call that Pac-Man. That is this. I want to put this as animation. So that animation. So another function that is defined here. Within that, I made another function animations. That animations coordinates, same coordinates, and then I need to have a for loops, right? 10 times. So the create arc. Arc I created. What is the arc? When I do this, then that is our arc. But this is his arc. I want to make that arc so we have 2 ovals and 3 arcs. These arcs can be done this shape and another shapes. So extended 320 and 290 and back to 320. This is a for loop. And I want to make a slip 0.5 milliseconds and then go back to original and 0.5 milliseconds. And then I fill the different colors. One time, initially this, and then green, blue, green, blue, green, blue. And then ovals. I have oval here. This is right now white, but it can be a black. Oval here, this is XY coordinates. This is like circle, but it can be another shapes. So this Pac-Man, you emulate this Pac-Man may behaves, may actively act something, but it is not really actively act something, but you repeat the different ways of shape generations. Okay, so watch that. If I remove this to top, and within this Pac-Man program, I want to after 1 milliseconds, I want to create animations. So animation needs to work here in this case. So see how it works. So when I want to Restart. Okay. I want to restart. All right. So I want to run. See what happened. Animations reference to before signed. This guy, right, in this, if it is an object orientation, it's not really the issue, but in this, what happens here, this guy does not understand the animation. So I want to put this animation somewhere here. I want to put that here, somewhere. This is the old one. Let's see. This is not animations. Canvas is not defined. Canvas is not defined. Where? This guy's canvas. So I need to do canvas. Canvas is not defined. Okay, let's do. Oh, very nice. Right, it is animated. One time green, one time blue. So green and blue can be done until I click that. So when I do this, you can, this arc initially, I think it is 100, or it's just 10 times, right? You can do this anytime until true, then you need to do here. So continually, right? So this can do continually. Oh no, sorry. It should not be doing like that. Then you need to do while, instead of for loop, then you need to do while. While true. This continually can do. So extended 390 degree to 320 degrees. When you go to 320, then you have to remove this arc somehow. I'm not sure how I can remove, but it's not impossible, right? Okay. There's a one homework assignments. What I want you to do. I want to remember. I have two, the previous and this. I want to put them together in the class definition. This is a I didn't use this in a class, right? So I want to make them together in one class code that is I need to restart. Okay. So it should run like this. It should run like this. Remember previously we had inside here, yeah, it was not the animate. There's no animation here. All are the same, right? I wanted to put two code together, and inside here that should be animated. Okay, let me give you one more time. That is the homework assignments. So, and then you can submit one Python files. That's it. All right. I'll see you next time. Thank you.